We're going to review the rational function because it seems like a lot of people get confused with the horizontal and vertical asymptotes, and they forget why it has both and what it means. So it's very simple if you remember the basics. Okay. Basic one that we had learned was the simple one, which is you could say a over x, k over x, whatever, it doesn't matter. I had given a very simple example as if you guys were renting a limousine for school, prom, a limo, and the price of the limo was $1,000. And then there was a scenario of how many people are going to this prom and how much would you be paying. So basically, there is certain scenarios, and we said, well, if x and y, so x would be representing the number of students or the number of people in the limo, and y would represent the dollars per person that they're costing, it's costing to them for the limo. And we said, okay, well, if 10 people go, because it's a 10-seater, then each person pays $100. If 5 people go, then each person will pay $200. If 4 people end up going, then of course they're going to be paying more. And this I'm getting by literally going y is equal to 1,000 divided by the x. So if 2 people go, we were making jokes in class and saying, well, people got into fights and now there are less people, so now it's $500 each. If then all of a sudden nobody wants to go and you want to go alone for some reason, you're paying $1,000. Then your mom said, well, not worth going if it's going to be $1,000 for one person. So guess what? No people are going. There's no point in renting a limo. Now, if you remember this, it's 1,000 divided by 0 gives you that very famous error. Nothing could ever have a denominator of 0. No denominator of 0. So remembering that the bottom number here represents your restriction. So x could never be 0. Now let's look at what that looks like if I make a really quick sketch. I'll make it really small so that we look at our table of values and we get an idea of what this is going to look like on a graph. So if we had 1 person going, 2 people going, 3, 4, 5, 6, 7, 8, 9, 10. So really quickly here, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So if 1 person was going, they'd be paying literally $1,000. As the amount of people go up, what is going on with the price? It's actually getting smaller. So at 6 people, 7 people, 8 people, 9 people, 10 people. At 10 people, literally, it was like $100. So as the x's are going bigger, the y's are getting smaller. Okay, this is a really lame drawing, but the whole point is to kind of see what this looks like. This will never touch the axis of the x-axis, so we call this the asymptote, because it's impossible to go if there's nobody paying. And this is actually considered decreasing. So this is a decreasing graph. Now let's go into the next screen and I'll show you the 2 general trends. Okay, so you have, let's see what you have. You have a graph and you have a potential of increasing or decreasing. Let's just see what that looks like. Okay, so if your graph is, this is the 2 most important things that you're going to look at. So your general standard version of the transformed rational function looks like this. Okay, knowing that your h is your vertical asymptote and your k is your horizontal, I'll write that in a moment. the most important thing to remember here is the A times B. If your A times B is bigger than 0, that means it's positive, then your graph will be decreasing. What does decreasing look like? It looks exactly like what we just did before, like this. In fact, you're going to have a mirror image of this on the other side, pending wherever your asymptotes are. So if your asymptotes are here and here, well, you're going to have a mirror image of that on the other side. Now, if your asymptotes are, again, here or here, or wherever they are, a decreasing one would look, an increasing one, would be when A times B is less than 0. What does that look like? Well, that looks like this version, never touching the bottom. Okay, so never touching the x-axis, never touching the x-axis here, never touching the y-axis. And this is considered, we said, increasing. Okay, having said that, let's do a problem from beginning to end to understand it and analyze it. So next screen. Okay, let's look at y is equal to 3, 2, x minus 2 plus 1. Okay, what you have to look at first is this right away. When will this fraction here on the bottom, when will your denominator be a 0? Well, your denominator, remember, cannot equal to 0. Therefore, x minus 2 cannot equal to 0. X cannot equal to 2. That's your vertical asymptote. If you don't know what, or you can't remember that it's vertical, just remember, how do you graph an x equals 2 line? Well, you graph it vertically, like that. So this is your vertical, and that leaves us with a k, and the k is your horizontal. So your k is going to be y equals 1. Now, I don't even have to make a table of values for this. I know one thing. I know that the a times the b is bigger than 0. Having looked at my previous screen, I remember that that means this is going to be decreasing. So really, all you have to do is draw your graph, like a table of values, not a table of values, sorry, the Cartesian plane. Put your asymptotes, and then just put what decreasing looks like. It's just a quick sketch for you to understand how to interpret the graph, like how to interpret domain and how to interpret range and all of that other stuff. Okay, so just look at what we have. We're going to put right away some numbers just to give me some sort of like indication where to put things. I'll try the black. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, and so on and so forth. Okay, I have a vertical asymptote at 2. So I'm going to literally go and draw a vertical asymptote right there. Then I'm going to go to my 1 and I'm going to put the horizontal. I'll try to make it, or whatever. You get the idea. Having some issues here. All right. Now, I know it's decreasing, and according to decreasing, the look goes like this. And it's a mirror image, literally. So it's like as if I have a mirror going down the side right here. So I'll just remove that line, but the whole point is like as if I had a mirror being diagonally placed. So it's reflected, like a bisector. Now, you see that the 0 is somewhere around here. My graph is not drawn to scale, so if you want precision, you're going to have to figure out what that 0 is by replacing the y by 0. For now, let's just figure out what is domain. So domain is all the x's. So your domain is going to be all the r's except the vertical asymptote, which is 2. So this, it will never hit it at 2. And range is going to be all your y's. And that's going to be everything except this, which is your k, and that's 1. So Always for a rational function, your domain will be all of R except your H. So it's going to be all of R except H. And for range, it's all of R except your K. That's pretty basic. Now let's figure out the zero, because the zero gives us an indication of, when is this positive and when is this negative. So let's figure out how to do the zeros. Next screen.